Hello and welcome to the final episode of this Stromberg Carlson. So we finished off the last episode with the everything wired up, and we went through what we'd actually done to this amp, to the channels and so on. But now we're going to fire this amp up for the first time, so fingers crossed it's going to fire up okay. We've got solid state rectifier in there. We've got a couple of meters up on this shelf here, you can see. One's monitoring the bias voltage and one is monitoring the plate voltage. Now we're going to use the variac as well as the current limiter on this one. So we're just going to start off with a little bit of voltage. So we switched on, and you can see now there, I've just turned it slightly, and we've got 5 volts going in there on the plates. So we've got 5 volts on those plates, but we don't seem to have anything coming in there. So we got on this screen. Oh, something must be wrong with this meter, because it's not. I've not shoved the probe in. The times I do that. Not shove the probe into the meter correctly. Let's try again, see what we've got up here. Yeah, we've got the voltage there, so we'll go up a little more. Turn some of these volumes up as well. Obviously we'll have nothing on the bias yet till the tubes start to conduct. There we go. How much have we got on the variac? 20 volts. I know we've got less than 40 volts, because here is the current meter. That won't work till there's 40 volts going into it. Just going around all the nodes there on all the plates now on these tubes, preamp tubes, pin 6 there. Yeah, I've got 10 volts there. That's matching what's on the meter. Pin 1 there. Yeah, I've got voltage there. So all the plates have all got voltage to them. So now I can go up a bit more. Let's go back onto the meters again. So let's just go up until we see 40 volts on here. Let's just stick another bulb in. Oh, you see, yeah, that's doubled it. So we've got 30 watts of bulbs. $50 milliamps, so we're not drawing any excessive current. So we've got 80 volts going through it now. Just let that sit for a while, a minute. Remember, we're still bedding these caps in, these new capacitors. I'm just going to plug into one of the inputs and put the scope on, the signal generator in the scope. Right. Now I've got 123 volts on the variac, and I've got 48 volts going into it. So I'm controlling that the voltage that's going into it with the bulbs, as well as the variac. Right, that's a 40 watt bulb in there now, and you can see that's gone up to about 120 odd volts now, and we've got 72 volts going in there now. You probably can't see that on there because the angle of the camera, but we've got 72 volts going in. So probably not enough to get the filaments going. I'm just going to ease the variac up a little bit more now, and we can see that we're beginning to get some conductance there on the output tubes, because you can see the bias voltage is creeping up, drawing 70 milliamps now. I can see the pilot light bulb is lit, dim, but it's lit. I'm not hearing anything yet. Now I would expect to hear some sound now, and I'm not hearing anything. Oh yes, yes, I can hear a bit of something now. 100 milliamps we're drawing. So the voltage now is 203 volts on the Variac. Just going to ease a bit more voltage in there. You can probably just hear that beginning to come up now. There we go. £178 volts, drawing 110 milliamps. I'm just going to put another 15 watt bulb in there. That should bring the voltage up more, and the sound's coming up now. Yep. Right, so let's try. That was the Masco channel that we added to the amp. So we've got nothing on that channel. Try the next channel. Yep. Yeah, we've got voltage there, sound there. Let's go to this one, and nothing on that one. We've got a couple of channels that don't work, but never mind, we've got two that do. We can sort those problems out. Right, so that's looking good. So we've now got 55 watts of bulbs. I'm going to put 80 in now. And that's much better. And yeah, that's fired up. Treble works. Bass works. The bass is a bit noisy. Not sure what's causing that. That could be a faulty pot. Faulty something. My word, that channel's got some oaky. Right. So we've got a bit of a microphonic tube somewhere. No problem. That 6SL7 is not very clever. Right, let's come out of that channel. That channel's okay. Yes, that 6SL7 is a bit of a problem. Don't know what's wrong with that. It's a new one, but it happens with new tubes. That bass control's very noisy. So we've got a few problems. So that's quiet. Until you turn that bass up. That bass is a bit noisy. That's something we need to look at. those two channels are pretty quiet. But it's just that bass control. I've got it fully down at the minute. By gum, this thing's loud. And obviously that channel's we've got a tube out of it now, so I'm just going to pull that pentode out as well. Out of that channel that we modified from the Masco. Nothing wrong with that pot. See, we never really got to test these pots properly because of the state the amp was in, and we know that this amp had quite a battering when it came over from the States. Got some feedback going on there. That's pretty quiet with the volumes down, isn't it, to what it was? And if you turn the bass down, it's silent. So the problem channel is this Masco one. We've got a few issues with that. We need to just check, and I think this volume control, we've got some issues with that maybe. I'm not sure. So we'll just use this channel. What we need to do now is increase the voltage a little more. Take these. So I'm going to just go with 140 watts now of bulbs, and that's bringing the voltage. Oh dear. So yes, we've got some problems somewhere. We start to put too much voltage on this, so we have got some issues still, and that pot seems to be a little bit of a starting point there. Right, so I've got a few problems with this, and I've just sorted one of them out, or rather just found what the problem is, and it's this negative feedback here. I've disconnected. That's what was causing the squealing. You can see that's so with that connected, I couldn't get above 80 watts of bulbs on the current limiter before that was going at it. Don't know why that is, because that is exactly how it should be wired off the schematic. We've got this stable now, pretty stable. We've still got, I think we've got a ground loop somewhere. If we turn that volume down on that channel, you can hear the ground loop on there, but also on this schematic, you might not be able to see it as clear without the macro lens, but on this schematic there, oops, sorry, there you can see that ground symbol there and those dotted lines. That means that should be screened cable. And there is a bit of an attempt with this. There's a bit of a cable here if we just look over this, which I left in and I should have replaced. So I'm going to replace that with some proper screen cable, and hopefully I can get rid of that. I think that's a ground loop I can hear, so I'm going to fish that out, find that. Now I've got a 12 AU7 in the phase inverter, and that's what's recommended in this amp, and there it is, 12 AU7. And this tone stack here, this tone stack tube, I've got a 12AT7 in there, should be 12AX7, so drop the move from 100 to 70, and that seems to work the best for me on this. We've got some very high plate resistors, 150k on here, as they have on the phase inverter, 150k plate resistors, which is probably why there's a 12AU7 in it. And like, well, a very strange way of doing it, but, and then this 150k on this tone stack tube as well. Now I've done some work on the channels, and I've put some 470k grid stoppers in, and I don't know why I didn't do that when I started this amp, because there was no way that there was going to be enough attenuation. Well, there wasn't any attenuation. Not showing any grid stoppers on here, as you can see. It's just going straight in there, straight in there, no grid stoppers on any of those channels, and they were just overdriven as soon as you turned up the volume slightly. Now I've got two of the channels really good. The Masco channel is just absolute poop at the moment. I've got problems with that and a lot of gain, but I spoke with the customer earlier, and I've made a bit of a boo-boo, because it's not the Masco MA17, it's the MU17 that I should have took that channel from. So, and that's just a single 6J7, so I might just convert that channel to that, and that will solve the problems with the high gain on there. And again, I've attenuated that, but it's just not worked. And also this fourth channel as well, we seem to have way too much gain on it. But channels 2 and 3 are pretty good on this now, and we are getting there with this amp. If we turn the bass control down and I turn the volume up, and that's the volume on the other, you see we've got plenty of white noise, but pretty quiet. So if I turn all the volumes down, it's not too bad. There's a bit of background noise because we don't have a master volume, as I've said. Can't completely shut down the power amp. Turn up and the treble's full up, there's a treble down. But if I turn the bass in, you can hear that ground loop kicking in. When the guitar's plugged into it, that's quite noisy, and that's because I think of that screen cable. So we've still got a couple of channels to sort out, and we've got some noise to chase down. So that's where we are. Channels 2 and 3 are pretty good. Channel 4 still needs some work, and channel 1, well, we may be changing that again now, because I put the wrong channel in there, which is no problem. It's not a big deal to change that. Now voltages, again you can hear that ground loop, and it's only when you turn up the bass. So now as I've said, we've got the solid state rectifier in this amp at the minute. Now if I connect on there, you can see we have 403 volts on the plate. We should have 425, and that is 420, sorry. So we're 20 volts light on there. Not a massive amount, but of course when we put the rectifier tube in there, then we are going to be missing some voltage. Let's pull the plug and just wait for that voltage to disappear off there, and it has. And then we'll pull out this, and it's absolutely caning my thumb, but it's out. So that's the solid state rectifier. So here's the rectifier now, the rectifier tube that goes in this amp, and it doesn't appear to be, oh there is, this is a 5DJ4, this one, 5DJ4, but that's not what we've got on here. We've got a 5U4GB on there. You probably can't see that, but that's the tube that was in it. But I am going to check 5DJ4, sorry. So we should be okay to switch on. We've got the current limiter on, and the bulbs went pretty dim, and you can see that rectifier tube there, the voltage comes straight up on that. Now flick the current limiter off, and oh dearie me, we only have 350 volts on the plate with that, and that's plate to ground, not plate to cathode. So a considerable 50 volt drop there. So we've got 27 volts there going on across the bias resistor. The bias resistor is 250 ohms. So let's see. 27.2 divided by 250 equals 108 milliamps. We'll divide that by 2, so we've got 54 milliamps per tube, and then we're going to take away 5% for the screen. That leaves us 51.6 milliamps. So 51.6. But now we need to take that 349, we'll call that 350, and we need to take away the 27 volts. 323, 322, and that's 16 watts we're getting out of those tubes at 53 milliamps, and that's because the voltage is down on there considerably with that rectifier. Right, so we'll switch off and we'll wait for that tube to cool down, and then we'll check the bias on the, now I've got most of the tubes in, we'll check the bias on the solid state one. Right, I've got the solid state rectifier back in. Let's fire up again. And you can see we've got 450 volts more now, just a shade over 50 volts more, 52 volts and 53 volts more. Just let the tubes warm up again fully, and you can see we've got 31 on here now instead of 27. The tubes are conducting more. That's now dropped 340 to 400. Right, so let's do the maths on this one. So 31.6 divided by 250, because that's our cathode resistor, and now got 126 milliamps. Divide that by 2, now got 63 milliamps, 63.2, and we've got to deduct the volts DC from the plate voltage, which gives us 368.4-ish. That's what I did that earlier. So times 368.4. Now they're running at 23 watts with that in. So a bit of a strange set out that. With the rectifier tube in, we're 3 watts under the 19 watts, and with the rectifier in there, with 4 watts over, with the solid state rectifier 4 watts over. So I've got another rectifier tube here, which is a 5V4G, and I'm going to check the pin out on that, and we'll try that in it. So let's see what we get out of this 5V4. We're getting 17.76 with that. So customer could probably do with a slightly better rectifier tube. That one could be tired though. Maybe it's tired. So we're getting 348 volts out of this. I've just had it in there again. We're getting 348 volts out of that. We're getting about 362 out of the 362 out of the 5V4, and the solid state rectifier is giving us 400 volts, but it's over biased in the tubes. So there we are, a bit of testing there. We've had another few hours on this amp. First thing I've done is corrected my mistake with the incorrect Masco channel, and I'm actually really impressed with this new channel that we've got now. So we're just going to have a look at this channel now that we've done, which is this 6J7 microphone channel. Now we've used the 6J8 for this, and I have to say it sounds pretty splendiferous. So we've got 470k grid leak, but I've got a 1 meg in there. 2.2k cathode resistor, and a 50 microfarad bypass cap. So we've kept that. We've got 2.7 meg. I only had a 2.2, and we've got the 470k in there as well. We've got a 0.01 capacitor for the bypass cap. We didn't use that 100. We didn't need it because we've gone into the volume, out of the volume, and then into those two 20k mixer resistors, so we didn't need that. And this does sound great. You see, we've got 25 volts, 35 volts on there. Because I dropped that, we've got about 50 odd on there, and probably about the same there. I can't remember. Not a lot of voltage on that, but it works really well. So yeah, it's a cracking channel, that one, I think so anyway. Now, the reason that the customer wanted this microphone channel was because for harmonica. I don't know how good that'll sound. I don't really know much about harmonicas, so we're trusting to luck with that. So that's what we've used for that. Now we've done some other bits. So this channel that had incredibly high gain was because I hadn't put a grid leak resistor on the second stage, although there wasn't one on the schematic, but I put that on and that's tamed that. That channel is still, and I can't really understand why. The only thing I can think of why this channel has so much gain, because it's got a 12k cathode resistor, but it's got one 150k plate resistor for the first stage, and it's got a 270 for the second, so I'm guessing that's where the extra gain's coming from there, without delving in too deeply. It's clean, but when you turn the volume up, it's loud almost immediately. I've dropped a 12 AU7 in there, so the customer has experimented in the past with this amp when it was running, and he has used 12 AU7s. He sent me a selection of tubes, but I've just dropped that in there. He can always change it. We've got 12 AX7s in the other two. What else have I done? Rewired the grounds on this base control here, and I've got rid of that ground loop. We've put some screen cable in there. I've put a screen cable from here down to there, grounded them all at the same point, because I shouldn't be grounding them off here, because it's there for the power amp stage really. And so I've grounded them down there, and that's a lot better. It's still a bit noisy when you turn it up, but these amps, you know, you're just never going to get them silent. It's just the nature of the way they're wired point to point. So I've done that. Anything else that I've done? Can't think. Probably is, but I've done that much to it now. I'm going brain numb. Now all the tubes are in it that we want in it, and it's running, and that whole side of it is finished. I've got a meter up there now which is monitoring the plate to cathode voltage. So if I plug in, that's got the original 5 DJ, I can't remember what that tube was now. So that's it for the plate to cathode voltage with that rectifier in there. I think was it 5 DJ4 or something. We'll check it again on when we take it out. 319 volts we've got with that tube. Not a lot, is it? Plate to cathode. I've seen more than that on an amp with 2 EL84s in it. Tested that tube and it wasn't great, and I just think he's tired. I looked at some specs last night on these tubes, and according to the data sheet, this 5DJ4 is a perfect match for the 5U4 that came out, that was originally in this amp when it was made, and this is supposed to be the same spec, and that tube is capable of delivering far more current than this tube which is the 5V4G that we've borrowed. Right, so I've just had this on the 4V12 and we're not going to hear the demo just yet. Changed a few things around, so I've now put a 12 AU7 into this tone stack socket here where the tone stack's wired. Still got 12 AU7 in the phase inverter, and I've changed these around. So channel 1 we've got 12 AX7, channel 2 we've now got 12 AY7, 44 mil on that, and we've got 12 AU7 in that in the channel 4. Channel 1 obviously is our 6J8 there, Russian tube, Russian 6J8. So I'm going to put, I've still got to get this amp on the scope, and as I say, I'm still waiting for those grommets, they've got to come. Now I've actually looked at this socket, and I kind of, while this amp's it's been upside down, didn't really pay much attention, and now this has got this Coke bottle rectifier in. We've got a bit of play in that socket, and that is catching on there with it being the Coke bottle. The other one probably did, but had a bit more travel. The problem with that is that if this is catching on here and vibrating when the amp's playing, we're going to have constant vibration going through that tube. So I'm going to change that socket. I'm not happy with it. And you know, I've got to get this amp spot on. This amp's going back to Scotland. That is over 200 miles away from me, so we don't want this coming backwards and forwards. Right, so I've got this amp on the scope, and as you can see there, that's the phase inverter you can see, and you're kind of looking at that and thinking, well, that's not too bad of a match. It doesn't match entirely. Unfortunately, you'd be wrong to think that, because look at that, 13.2, 5 volts. And just to put that into perspective, if I start to bring that down, and I've got this on fine at the minute because I was just trying to get a, so 5 volts. Look at the difference in that. So we've got major problems, and this is again the Masco that we did last time. A similar type of, this is a long tail pair phase inverter, and it's wired very similar to what the Masco was. Going to measure, and if we look at peak to peak on there, which is there, you can see we've got 38 volts going on. So if we go, let me just switch off channel 1, don't worry about that, it's because the triggers. I'm going to measure there, oops, 10 volts peak to peak. So massively imbalanced, that phase inverter. So we need to sort that out. So most long tail pair phase inverters, you've got the grid, one grid taking the signal and the other grid to ground. On most modern amps, that's usually a capacitor to ground, 0.1, something like that. This amp has got a resistor to ground, an 18K. Although I've cut that out and I've got a 15 jumpered in. I've been experimenting with that. Now you can see on the green channel 2 there, you can see that it's slightly rounded off. If we bring that down, you can see there, you look down there and there, you can see that that's not matching. So I'm going to remove this resistor. I'm going to put a 0.1 capacitor in. Now look at that, and if we just bring the position back up a bit, and now you can see that matches perfectly. Obviously it's not matching as the input signal because we've got as I say, we've got that massive imbalance, but the waveform's matching is what I mean. So if we go into here now, and you can see we've picked up a couple of volts on the peak to peak as well. So that's this is all a juggling of components. So the next thing is to try and balance the inputs. And if we go back, oh sorry, that one. Again, if we go back to 5 volts on there, you can see there's a massive difference going on. So we need to reduce that difference now. Right, so I've increased the cathode resistor from 4.7k to 10k. Now you can see that channel 2 has increased in gain. It still doesn't have more gain. Let's see what we have got. Whoops, see what we've got now. Now we've got 14.6 on there. Let's see what we've got. And we've got 25 volts. So we're about 11 volts now. So we've just about halved that deficit. So now you can see we've got 3.62 and 2 volts on there. Now we are losing gain on that phase inverter, but we could get that back by putting in a 1287. So so remember our gain was 34, it's now 25 on there, because obviously now the tube's biased colder, so we're not getting as much gain out of it. But I have a 1287 here, so let's pull out the 12AU, which also is a lot cooler to touch now, because that was rather hot earlier. So we'll just put that in, wait for that to warm up and see what we get. And you can see that's just about put us back to where we were before. So it's all a juggling act really. But of course we'll still have more gain, because whilst we've lost some on one side, we've gained some on the other. So we probably still have too much gain with that tubing, and in actual fact, if we just turn off measure, you can see we have, because the scope's gone off the scale now. So we're still good for a 12AU7. Right, now I've got a 15k resistor in there. And that's balanced it even more. Let's see what. Now the gain's down to 20. What we got on the other one? 13. So now we're only about 7 volts. Light. Oops, what did I press there? Pressing buttons everywhere. There we go. Press the maths on that. There we go. So still not matched, but we're a damn sight closer now. Now I could probably put a 22k in there and we'd probably get that matched. We could drop a plate resistor, of course. That would also give us less gain on channel 1, which is what often happens on some long tail pairs. You'll see at 82k and 100k, that's to balance up the phase inverter, which is what we'll probably end up doing just to finish this off and get it balanced. Now, does the phase inverter have to be perfectly balanced? Well, according to most things that I've read up on, no. But obviously peak to peak 25 volts out is a 25 volt difference. Obviously there's unbalanced and unbalanced. That's very unbalanced. So no, we need, if it's close, it'll be fine. But some people may argue and say it does need to be a perfect match. But then again, some people say it won't. It's really, that's just down to, you know, whatever you read up and whatever you decide to take. I can't explain the technical details of that. As I've said before on this channel, you know, I'm a competent tech. I'm not an amp builder, I'm more of an amp repairer, although I've kind of built this. And when it gets to really advanced maths and things, my maths is okay on most things on here, but when it starts getting to phase inverters and working out, is it okay to have an unbalanced one, or is it okay to have a balanced one, then, well, I just leave that to the designers. Right, let's jump into 22. Now, just a word on safety. What I'm doing is I'm jumpering in these resistors, and it's wise to switch off when you're doing this, and if you're not, then make sure that you don't get between ground and the cathode feed coming off the tube, because if you do, you might find you get a nasty nip. So I've got 22k resistor in there now for the cathode resistor with the phase inverter, and you can see now we're down to 19 volts peak to peak, about 19.5 volts peak to peak there. And you can see if you look at the waveform. Right, now let's swap it for the 12AT7, and now I've got 22 volts there peak to peak, which is not a lot more when you consider how much gain there is on that tube. And now if we put in a 12AX7, and now look, we've now only got 17 volts peak to peak, and look at the waveform there, it's clipping, so that's distorted. Put 2.2 in there, and you can see the gain's gone up to 25. If we just bring those down, let's move position, you can see now that that's clean on the top. So what happens is, as you increase the cathode resistor, the phase inverter just becomes less efficient. If you start ramming in the ECC83 with a mute of 100, your phase inverter is just overdriven when you turn it up, and that's not what we want for this amp at all. So a balance has got to be set here on what we actually use for a cathode resistor. So go back to the 22, and you can just take the measure off, and you can see there, turn up the volume, so that's all wrong. Now let's put the 10k in with the 12AX7. Better, but still not right. So let's remove that, and let's put in the 12AT7, which is an ECC81 if you live in the UK, as I do. And you can see that that's much better. So the 12AX7 is not right for this phase inverter. You have to, and this is the thing with phase inverters, you know, people are swapping and changing tubes and thinking, oh, I'll just put a, you know, get more gain out of it. But are you actually gaining anything? No, not really. You just, you know, and I suppose if you like amps high gain, it's cranked up, and that's, you know, a pleasant distortion that you get out of it, then you've probably had a result. But if it's not, then it's never a good idea. These phase inverters are balanced by engineers who really know what they're doing. The only reason I'm balancing this phase inverter is because it's so out of balance. And you know, probably when this amp was designed, maybe they just didn't bother about things like that as much. I don't know. It was, you know, designed in mid-late 50s. I don't know. But normally I wouldn't be playing around with a phase inverter. I would, you know, it's been designed by an engineer who designs amps. I don't design amps. I repair amps. Yeah, I'll build the odd amp, but I'm not an amp designer. That's a far greater qualification than I have. But in this case, we've got no choice. We've got to balance it because it's miles out, and you know, sometimes you come across these things, so we have to just find a workaround. And you're learning from all the things that you do. You know, you're learning all the time, and I'm videoing this, so you know, hopefully you can learn from it too. What all this is about, this phase inverter thing. They're very complex things, phase inverters. Probably one or two engineers sat out there watching this going, puh, no they're not. No. Which is probably when people see me playing guitar and I'm saying, oh, that's pretty easy, and they're going, puh, no it's not, it's just what you're good at. At the moment, let's see what our peak to peak is now. It's only 15 volts. Of course I have altered the volume now, so we've lost that scale of what we was trying to do, but irrespective to that, we got 50 volts peak to peak flat out now on the phase inverter there. And let's see, let's just go, just want to change the menu on here as well now, so we need to make this coarse. It just makes it easier to adjust. So we go to, and we'll have to come down on that. Let's just remove measure. Let's just see what that looks like when it's cranked. And you can see, but the amp is flat out now. We're on with the 12AX7, we was getting that long before the amp was flat out. Let's just back the amp off, and you can see, so only on that last bit of volume are we getting that overdrive on there. Let's try some of the other channels then. Let's try channel 1. Yeah, and again, just let's try channel 2. Yeah, channel 3. Yeah, and channel 4. Well, that was the bass I was turning. And you can see channel 4 isn't clipping as much when it's cranked there on the phase inverter, because that channel has got it's got the cold clipper cathode resistor, so probably just don't have quite as much gain on that one. So we've got a 10k resistor in there now, and we've got the 12AT7 in there. Let's go on to measure. So we've got 40 volts peak to peak now on channel 1. We've got 29 volts. So we're 11 volts out. So we're going to see now, does more gain on the tube get a better match? So I've got the 12 AU7 in now. So we're at 2 volts per division. So you can see we're about a division there, 2 volts difference. Let's go for the 12AT7. And you can see now that the match is just slightly closer there. Let's remove him. And we'll put in the 12AX7. So I'm altering that with the volume. So you're getting quite a close match with the 12 AX7, and you can see we're getting less a match with the AU7. You can see the difference there on there. So you get, with more gain, with a higher gain tube, you get a better match. That's the match we've got with the 12 AU7 in there. And what I've done, I've dropped one of the higher gain side on the phase inverter that we had. I've dropped the plate resistor down to 100k from 150. So you can see they're not quite a match, but much closer. Let's just check the gain on there. The difference. Oops, what am I doing? So you can see we've got 12.6 and we've got 8.8 volts now. Just 4 volts out. Let's just turn it up a little bit more. And that the amp's flat out at that. I'm on channel 2. So a little bit out. Let's put in the 12AT7. Let's just pop the 12AU back in. I just want to. So the amp's flat out with the 12AU. We'll go for the maximum peak to peak voltage there is 64, about 64, we'll just say 64 volts, it's near enough. Let's put the 12AT7 in now. Let's just go back. Oops. And you can see now we've got a little bit closer match there. Just set it somewhere on the range. So we've got 20 volts there, and we've got 16.8, so 17 volts, near enough. So now there's only 3 volts difference. Crank it. Now I've got 46 volts. Let's have a look what we've got on the other one, which is what the one we actually did check it from, 66. So you can see when it gets cranked up, the difference begins to increase there. Let's go to our friend the 12AX7 and look at that. That's almost, in fact that is a perfect match. So you'd be thinking, oh well, we've hit the jackpot there. But look what happens when we turn it up. And look at the peak to peak voltage. It's only 23. And you can see that when it's cranked again, the imbalance begins to get greater there. And so that's the flat out on channel 2. So if we come down to about number 8, you can see that's almost matched. Number 7, by the time the amp's halfway, it's matched. But the problem is that's not the right tube. It is, and you're not necessarily. So this thing, oh well, I'll put a 12AX7 in, I'll get more gain. You actually don't, and the complexities of that is all to do with the efficiency of the 12AT7 and the swing. You get a greater swing with that tube, but that would need someone of greater technical knowledge than me to explain. Whilst I can physically demonstrate that, explaining it from a teacher's perspective would be foolish on my part. So I'm going to go with the 12AT7 because that's close enough for me, and we've got, in actual fact, it's just more efficient. I may still I may still change them over in the end. It's because with me it's what it sounds like. If the amp's not stable with that AT7 in, I mean, you can say, well, putting that in, reducing that 10k resistor on the cathodes and reducing that 50k resistor has reduced the gain. So to put a 12AX7 in, you'll just get that gain back and you'll be back to where you were. Not necessarily so. But that's not too bad. It's certainly better than it was before. We were absolutely miles out. 25 volts peak to peak when we started this exercise. Oops. Now I've got 12 on there. And 12 on there. So again, a close enough match. They're pretty close. Even with the 12AT7 in there, we've got a closer match. Not so with the 12 AU in there. Now then, the other thing is, what does the amp sound like? You know what we've done. We've just made a lot of alterations there. How will it have affected the sound? Will it have improved it? Well, I have to tell you, I had to go on this amp last night, and it sounded pretty splendiferous. So I'm hoping it still does, because for me, as a guitar player, the sound is a lot of these guys, these engineers, they're not actually, some of them aren't musicians, or if they are, they're not, they can play a bit of guitar. Most techs can play a bit of guitar, but for me, I'm a guitar player, period. And so the sound for me is everything. Not, I've done this because obviously that's miles out. I'm not bothered if that's a little bit out and this amp sounds phenomenal. I wouldn't be bothered if it was a little bit more still out. 25 volts was too much in my opinion. But if we're even 7 or 8 volts out and it sounds brilliant. I mean, the amp sounded brilliant with it 25 volts out, but obviously that was too much. So we balanced that up. Bit of waffling as well. And I welcome what you've got to say about this in the comments. Don't berate me. As I've said before, I am not an amp designer. I've come across a problem here and I've fixed it, and that's it. Some of you guys know far more about this stuff than I do, so let me know in the comments. And yes, we'll solder that 100k resistor in, because I've got that jumpered at the minute, and we'll then, in fact, before we do that, let's just leave that. Let's just get the scope on the output now. I've got the scope on the output stage now, which is connected to the speaker output. Obviously we've got dummy load on there. So let's just go through each of these channels. So that's channel 1, and we just need to go up a bit, don't we, on there. You can see just a little bit of clip in there. Oops, turned the wrong control. See what we've got. Peak to peak. 50 volts. That's the max we're getting out of it on channel 1. 19.5 watts we're getting out of that. 19.5 watts. Let's go to channel 2. See what we're getting on that one. Just a little bit more there. A little bit more gain on that channel. Channel 3. Quite a bit more, and you can see, we just turn the measure off so we can have a look. You can see we've got just a bit more clipping on that one. Let's go to measure. So yeah, 54. We're getting 22 watts maximum out of that. Remember, these six L6s are only 19 watts dissipation each. That's channel 3, and finally channel 4. We don't expect to get as much out of channel 4, and no, we're not, look, nowhere near. And that's again because of that cold clipper resistor on that channel, on that input channel there, so we get quite a bit less on that one. So channel 3 has the most gusto out of all of them. But there we go, that's all looking good. 5, 4, 3, 2, 1, sync. Right, we've got this Stromberg ready for the demo. Well, this is actually the second demo, because I had this amp running for quite a while, for about an hour or so, and when I come to play it, it sounded like the bias had gone off it almost, and it sounded dreadful. So I did a bit of checking, experimenting, swapped the output tubes, tested it with another set, and while I was doing the demo, it started going down again. So I know it's not the output tubes, and I've traced it to this, what I think is this 12AT7, which is military spec, that we put in the phase inverter. And since I put that in, it's now behaving itself. Also, the bit of frying we had has gone. So I think that tube was a bit dodgy. In actual fact, I've put a 12AU7 in because I couldn't find another AT7, and to be honest, it sounds lovely with the AU in, so I'm going to leave that. Just so much brighter, unless of course it's because that tube's tainted, but it works fine with an AU in it, so I'm going to leave it. Quite happy. Yeah, the phase inverter will be a little bit out of balance, but nothing. So we're in channel 1. And this is the 6J8 Pento channel, which is from that Masco MU17 schematic. This amp's got loads of bass on it. Bass is about 3/4 in there. That's about halfway if we go to 10 o'clock. Let's crank this channel, and then we can come down on the master volume. break up there when it's cranked, but hardly any at all. Just a little clip. And if we put this at about halfway and bring the master up, so that's channel 1. So let's have a look at channel 2. Let's crank it. Channel 2, that's the most potent of them. But again, you know, if we bring a bit more mastering, a little bit throaty, I'd say that one is, rather than, you know, it's just nice. You can just get some really nice clean, just clean but clipped classic rock sounds out of that, or some nice blues out of it. Let's try channel 3. Channel 3. So channel 3 has got the 12 AY7 in there. Now I should get quite a bit of bass out of channel 3 because we've got a 100 microfarad bypass cap on the first stage. You can get quite a good chunky bassy sound out of that one. But you can on all the channels, you can just more so on that one. Just a little bit more top on this when we're on the neck pickup. master up to about halfway. You can see it's brightened up a bit more now as we get the volumes up. So that's channel 3. Let's crank it. Whoa. That's channel 3. Swoop into channel 4 in there. Now this is the coolest channel of all of them because it's got cold clipper 12k cathode resistor on the first stage, and that's per the schematic. This was the auxiliary channel, and it's also got 12 AU7 in there. Let's crank it. And there we go, that's clean really, all the way up. So there we go. that sounds pretty awesome. It really does. You know, I think my favourite channel probably is this pentode channel, this, because 6J8, because I really do like these pentode tubes. Rusty, must practice more. But there we go, that's the Stromberg Carlson AU57. What a massive project that's been. It really has been a tough one. There's probably one of the toughest I've done, and it certainly pushed me to my limits. But all done now finally. So there we are, so that'll do it for this one. So thanks for watching, you all take care, and I'll see you all in the next video. Bye bye for now.